In this video, let us continue to solve problems based on probability. And we've got a problem here which reads like this. One card is drawn from a well-shuffled deck of 52 cards. Calculate the probability that the card will be an ace and not be an ace. Now, here it's pretty simple. There are like 4 aces in a deck, right? So we need to see like what is the probability that the card will be an ace. So there are 4 aces in a deck. So there are definitely, 4 times there are chances that you could pick up an ace. That is, let E be an event. The probability of event here, E, let it be the card is an ace. So the number of outcomes favorable to probability of E, that is P of E, is nothing but 4. Favorable outcomes here is nothing but 4, right? So, but what is the total number of outcomes? Total number of outcomes is 52, right? 52. Because there are totally 52 cards in a deck. There are 52 cards in a deck. So it can be anything. So you'll have to take everything into consideration. So that's going to be the total number of outcomes. So therefore, the probability of the event happening, that is the probability of it being an ace, is going to be 4 favorable chances out of 52 possible outcomes. So that's going to be 4 goes 13 times in 52. So the probability of the card being an ace is 1 by 13. So that is the probability of the card being an ace. So now next, now we've taken let P of E be the probability of the card being an ace. So here in this case, in the second case, let's take P of F being an event where the card is not an ace. So the number of favorable outcomes for this is, the favorable outcomes is 52 minus 4, because if you take 4, it's going to be an ace. It should not be an ace, right? So it should be 52 minus 4. You need to subtract those 4 outcomes, which is an ace. We are looking at not being an ace. So it's 48. These are the favorable outcomes. There are 48 favorable outcomes of the card not being an ace. So therefore, and of course, the total number of possible outcomes are equals 52. So therefore, the probability of the card not being an ace is 48 divided by 52, which simplifies to 4 goes 12 times in 48 and goes 13 times in 52. So the probability of the card not being an ace is 12 times out of 13, whereas the probability of the card being an ace is just 1 time out of the 13. So there is another way to calculate this 12 by 13. We just have to, use the complementary events concepts and find the probability of the card not being an ace. Well, what I'll do is I'll just leave it to you to just go ahead and use the complementary events concepts to find out if you still get 12 by 13. If you still get the probability of the card not being an ace as 12 by 13, even if you use the concept of complementary events. So, this is another simple problem, not very complicated. So this ends this problem. So before we end this video, let's quickly solve another problem based on probability. Alright, so here we've got another problem which definitely looks really lengthy. Nothing to worry about, it should be a simple problem. It reads like this. There are 40 students in class 10 of a school, of whom 25 are girls and 15 are boys. The class teacher has to select one student as a class representative. She writes the name of each student on a separate card, the cards being identical. Then she puts card in a bag and shuffles them thoroughly. She then draws one card from the bag. What is the probability that the name written on the card is the name of a girl or the name of a boy? So it's like pretty simple. The total number of outcomes, the total possible outcomes equals 40, right? Because there are totally 40 students here. So the number of the outcomes favorable for a card with the name of a girl is how much? It's going to be 25 out of 40, right? So let it be P of G, the probability of the outcomes favorable, for a card with the name of the girl. So that is going to represent P of G. It's going to be 25 because there are totally 25 girls. So therefore, the P of a girl the probability. Now, this is still not probability, it's just the possible outcome, just representing it. So the probability of a girl's name coming on the card is going to be 25 out of 40, because there are 25 girls' name out of a total 40 students. So it's going to be 25 by 40, and 5 goes 5 times and it goes 8 times in 40. So the probability of a girl's name coming in the card is exactly 5 by 8. And the number of outcomes favorable for a card with the name of a boy, here you can solve this in two methods. You can either, use the concept of complementary events, because if you want to find out the probability of the name of a boy coming, it is the same as the probability of the name of a girl not coming, which is nothing but 1 minus 5 by 8, right? So you can use that, or you can use the number of possible outcomes, or the favorable outcomes with a boy's name, that is P of B, is 15, because there are only 15 boys. So the probability of a boy's name coming on a card is exactly 15 by 40, which is again 5 goes 3 times in 15 and 8 times in 40. It's 3 by 8. So 1 minus 5 by 8 is also 3 by 8. Solving it in the procedure is also 3 by 8. So, well, it is looks like a huge problem, very lengthy problem, but that's all is the answer. It's very, very simple. So that's that with probability. So finally, if you add these, you get 1. So definitely the probability of the name of a girl coming in the card and the probability of the name of the boy coming on the card, these two events are complementary because they sum up to 1. So this ends this problem as well as this video. I'll see you in the forthcoming videos with more problems based on probability.